Alright, for this lesson, we're going to be looking at trigonometric equations, but the special cases, alright? The special cases of trigonometric equations, right? So I've already created a video where I gave or discussed the fundamentals for trigonometric equations and also covered the most basic examples you can find or problems that you can find for trigonometric equations. In this recording, I want to focus on the special cases. The special cases, it's those type of problems that you could find maybe in an exam setting or even in a class test. Okay, so yeah, yes. But the idea of solving a trigonometric equation still holds. You need a trigonometric ratio as a function of theta equal to some value or constant, right? It means that in your equation you need to have only one trigonometric ratio involved, right? Involved. So like in this first example that we have, let me just write it here. Example. Let's have our first example. So let's say I have something like, let's just keep it a bit simple for now. 3 cos theta minus sine theta. Minus sine theta. I'm not sure if this is gonna work out. It's gonna work in my favor, but for now, let's just say sine come this side, u that side. Yeah, it's fine. Okay, so this is our first example. The first problem we encounter with this problem is that I have 1 and 2 ratios. I have 2 ratios under the same equation, but the generic form says what? You need only one trig ratio or function as a function of theta equal to some constant, right? So I have to maneuver this or work around this or simplify this to something that looks like the generic form. Okay, so the first thing I can do with this one is get sine to the over to the other side. I now have 3 cos theta equal to sine theta. Okay, sine theta. Then what I do next is dividing both sides by cos. This cancels this. I'm now left with 3, and sine over cos, I know that it's equal to tan theta. You see what I did? I divided by cos on both sides. Maybe you may be wondering, why divide by cos and not by sine? I know that by having a ratio as sine over cos, I know that this is an identity of what? Tan, right? I know that sine over cos is an identity of what? Of tan. So this, actually dividing by cos, allows me to reduce the equation to one trigonometric ratio, that is tan. Had I divided by sine, I was not gonna have a case where I wind up with a one trigonometric ratio, right? So let's say maybe I did this: cos theta equal to sine theta, and divided by sine instead of cos. This over this gives me 1, then 3, and you see I have a problem now, right? I have a problem. There's nothing wrong with this. You're gonna end up with a cot theta, but for level 3 we do not deal with inverse, the reciprocals for the functions, for trigonometric functions, your sine, cosine, and tan. All right, so hence that is why I decided to go with what? To go with dividing by cos on both sides of the equation. Now I have a trigonometric function, a trigonometric ratio is a function of theta equal to some value. Now we can go ahead and solve for this equation. So in this example, it says theta is an element of 0 degrees to 360 degrees, meaning that the theta should be between 0 degrees and 360 degrees. Okay, let's calculate our theta now. But first we need the reference angle. The reference angle is equal to arctan of 3. What's the answer? Arctan of 3, yes, it's 71.565 degrees. All right, 565 degrees. Now, next question. Where is tan positive on the cast diagram? On the cast diagram. So tan is positive where? First quad and third quadrant, right? So in the first quadrant, we do not have any reduction formula. So theta in the first quad is just gonna be 71.565, and then in the third quad I do have a reduction formula over there. It's 180 plus theta, so theta is gonna be equal to 180 plus this, which is 71.565. Come on. So it's 180 plus 71.565. Answer 251, not 551, 251, 565. So these are our solutions. Okay, these are the solutions. All right, next example. Now in this case, let's say I have this as an example. 3 cos squared theta minus sine squared theta equal to 2. So here we have a bit of a problem. We have a bit of a jam now. Okay, we now have a bit of a jam. Now, the cos and the sine are both squared, and it's equal to some value. Okay, and the rule says what? When it comes to solving trigonometric equations, you need a trig ratio as a function of some unknown angle equal to some constant or value. I have 1, 2 trigonometric ratios under the same equation, right? Under the same equation. So in order to simplify this, what do I do? More especially if there are squares in your equation, if your ratios are squared, do this. Change one of these to okay, in this case what I'm gonna do is I'm gonna use the square identity, the sine squared theta plus cos squared theta equal to 1, right? And change this cos squared theta and write it in terms of sine. So I'm gonna do this. Use sine squared, I'm gonna transpose to the right hand side. I'm now left with cos squared theta equal to 1 minus sine squared theta, meaning that this is gonna be 3 in bracket the cos squared. In terms of sine, it's 1 sine squared theta minus sine squared theta equal to 2. Let's multiply. I'm now left with 3 minus 3 sine squared theta minus sine squared theta equal to 2. This and this are like terms. I'm now having a 3 minus minus 3 minus 1, that's minus 4 sine squared theta equal to 2. Let's transpose the 2, I mean the 3 over to the other side. This is equal to 2 minus 3. Remember, we want to isolate the trigonometric function and equate it to some value. This is what we are aiming for here. Then divide both sides by a minus 4. This cancels this. I'm left with a sine squared theta that is equal to 2 minus 3. It's minus 1 over minus 4. The answer is 1 over 4. Since I want to solve for theta, for theta, I want to isolate the trig function. It shouldn't be squared as well. It shouldn't be squared. It should be just the trig function as a function of theta equal to some value. No square, no square root, no 2, no whatever on the side. It should be just that trigonometric ratio. So I'm going to take the square root on both sides of the equation. So I'm now left with the sine theta equal to, so by taking a square root of a number, you're gonna get a plus or a minus 1 over 2. So the square root of a quarter, square root of 1 over 4 is equal to 1 over 2. So plus minus 1 over 2. So this is sine theta. Now we can actually get our solution, okay? But your solution is split into two. You have the positive half and another sine theta that is a minus a half, right? So I need to work out the solution for this and work out the solution for this. We start off by what? Getting the reference angle. So arctan of sine, it's a half equal to shift sine of 1 over 2. The answer is 30 degrees. 30 degrees. So even here, the reference angle is also gonna be 30 degrees, right? Remember, when we calculate the reference angle, we do not include the negative sign, right? So that is why I'm saying I'm gonna get a 30 degrees and a 30 degrees. Okay, so for this one, I'm gonna have two solutions here. So using cast diagram, I'm gonna locate the solutions, the quadrants for our solutions. So I have the reference angle. Now I have to ask myself, where is sine positive, second quad and first quad? So it means that we have two solutions, one in the first quadrant. So this one is just going to be theta equal to 30 degrees. I'm also going to have another solution in the second quadrant. So theta is equal to 180 minus the reference angle. Remember, I am using what? I have to use what? Reduction formulas. So 180 plus 360 minus theta. Okay, so equal to 180 minus 30, that's 150. Yes. All right, so for this part of the solution, I'm gonna have two solutions again, where sine is negative. It's negative in this quad and this quad. So my first theta is in the third quad. So theta is going to be equal to 180 plus 30 degrees, which is 210 degrees in the third quad. Then in the fourth quad, I have theta that is equal to 360 minus 30. Then theta is just going to be 330 degrees in the fourth quadrant. So this is our set of solutions for that example. Moving on to the next example. Let's take this one. 6 sine squared theta plus 5 sine theta plus 1 equal to 0. Remember, our equation should look like this. Trig function, trig ratio as a function of theta equal to some constant or value, right? Okay, so this is another interesting problem. Let me put it that way. It's an interesting problem. Why? What I see is somewhat like a quadratic equation in disguise. I have a sine that is squared and a sine that is not squared. If we look at sine as x, this is no different from this, plus 1. Oh, it is a quadratic equation, right? It is a quadratic equation. So, in order to resolve this equation and end up with something that looks like this generic form, trigonometric ratio as a function of theta equal to some value or constant, we have to factorize this, right? So I don't know how your factor how well you know your factorization, right? But you can also use the quadratic formula. Yes, you can also use the quadratic formula, but I'm just going to stick to the factoring method for now. So here it's going to be a 3 and a 2 sine theta and then a plus 1 and a plus 1. So 1 times 1 gives me this times this gives me that. So in order to confirm the middle term, I take this multiplied by that. I'm getting a 3 sine theta. This multiplied by that, it's a 2 sine theta. When you add the 2, you get a 5 sine theta. So it gives us the middle term. So confirm the factors are correct. Okay, so now using the zero factor law, I'm now going to have a 3 sine theta plus 1 equal to 0, or 2 sine theta plus 1 equal to 0. So the answer here is going to be a 3 sine theta equal to minus 1. Remember, we have to isolate the trig ratio and equate it to some value. I'm dividing by 3 on both sides. So sine theta is equal to minus 1 over 3. And doing the same for this, I'm going to have a 2 sine theta equal to minus 1. Divide 2, cancel. I'm now left with a sine theta equal to minus 1 over 2. Okay, now I have a ratio as a function of theta equal to some value. A ratio as a function of theta equal to some value. So if the factoring method it's showing you flames in here, you know what, just stick to the quadratic formula. But here you're gonna say sine theta is equal to minus b plus minus 2 square root of b squared minus 4ac over 2a, right? Over 2a. This is a quadratic equation. How do I know? There's 1, 2, 3 terms. The first sign is squared, the next sign is not squared, and the last term does not have any sign. It is a quadratic, right? It is a quadratic equation. So now I'm gonna have sine theta is being equal to minus, what is b? B is the coefficient for the sign that is not squared. It's going to be a 5 plus minus the square root of b squared. It's 5 again, squared minus 4. A is 6 over c, that's that's 1, divided by 2, a, that's 6, sine theta is equal to, let's solve this, open bracket, no, minus, open bracket, 5 plus the square root of 5 squared minus 4, 6, then 1, close bracket, then I have a 2, 6. The first one, it's minus 1 over 3, or sine theta equal to, then we change this sign to be a minus, equal to a negative half, same as this, okay, same as this. So it's not a train smash. If you don't know this method, if this method like it's defeating you 100,000 times, just stick to the quadratic formula, okay? Then you know reference angle. Let's get the reference angle. So shift arcsine of 1 over 3. It's 19.471. So this is the reference angle. Remember, you do not include the sign when you calculate your reference angle. So ref angle is equal to, we now have a half, 30 degrees, okay, 30 degrees. Now let's get the solution for this one. Where is sine negative? Cast, C-A-S-T. Where is sine negative? This quad and this quad. So it means that my theta is going to be equal to 180 plus the reference angle 471. Theta is equal to 180 plus 19.471 is equal to 199,471, right? And then we also have another solution in the fourth quadrant. So theta is gonna be equal to, 360 minus the reference angle 19.471. Theta is equal to this, 360 minus 19.471, 340, 529 degrees. Then I'm gonna do the same thing with this solution. Where sine is negative, then you work it out, okay? Then you work it out. Yeah. Next example. Next example. Let's take this one. Perhaps we can take this one. Let's take this one. I have a sine theta in brackets that is being added to 30 degrees equal to cos theta. You see what's happening now? There's a red flag. Red flag is that I have 2 trigonometric ratios in the same equation, right? In the same equation. And mind you, the angles are not the same. I think it was going to be a different discussion if we had something like so. Oh, okay, I have 2 different ratios. One is sine, the other one is cos. Okay, the other one is cos, and the angles are the same. I was gonna do this: divide both sides by cos theta. This divided gives us 1, and then this gives us what? Tan theta. But here I cannot employ the same logic. Why? The angles are not the same. So yeah, it's a tight grip. It's a very tight one. But this is where we apply identities such as co-functions. We're going to apply the co-function identity, right? This is what we're going to do. We're going to rewrite the cos theta as sine, in terms of sine, like this. Sine theta plus 30 is equal to sine, open bracket, 90 degrees minus theta. Okay, let that sink in. In 5, 4, 3, 2, 1. Sync on. Are you getting it? I hope you do. Look. The reason why I'm doing this, I'm using the co-function formula so that to write cos as sine. Yeah? To write cos as what? As sine. The moment the ratios are the same, I can just drop them and equate the angles. 90 minus theta. Now, since this right hand side was positive all along, be positive this whole time, it means that when we get here, there's no need for us to actually find our, what do we call it? There's no need for us to find a reference angle. No need for us to find the reference angle. So what we do is identify the quadrants using cast where sine is positive. Where is that? Which quadrant is that? Second quad, first quad. So for the first quad, it's just gonna be the theta plus 30 equal to 90 minus theta. Then we solve for theta. So theta on the left hand side, it's theta plus theta. 90 stays. 30 degrees come over to the right hand side, it's minus 30. Then it's 2 theta equal to 90 minus 30, 60, 70, 80, 90. Yeah, 60. Divide both sides by 2, then theta becomes 30 degrees. Now, for the second quad, it's just going to be theta plus 30 degrees is equal to, since the reduction formula here is 180 minus theta, it's just going to be 180 minus the 90 degrees, this angle, minus theta. Theta plus 30 degrees is equal to 180 minus 90 plus theta. So this plus this is equal to 90 degrees. 90 degrees plus theta, and then when the thetas are gonna cancel. Okay, so once this cancels out this, let me show you theta, this theta when transposed to the left hand side is going to be a minus theta. 90 degrees minus 30, this minus this gives us 0, and then this gives us 60 degrees. 0 does not equal to 60 degrees, so we say there is no solution for this one. Okay. I know there's a lot to digest here. Just drop your thoughts in the comment section of this video. Let me know if you need more examples for this, for these types of trigonometric equations. I'll create another video, no problem. But for now, I think this is enough for this lesson for today. I hope we enjoy it. Leave a like. I don't know, leave a like, on a question, just drop it in the comment section. In the description box, I'll leave links for other recordings that are relevant for this discussion. So thanks for watching, guys. I'll catch you on the next one.